Hello, 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 everybody. I hope you're all doing well and you're ready to finish off our 2011 Part 1 Alberta contest. Because we've got question number 16, and that is the last one left to do. For any real number r, this is called the floor function of r. Floor of r is the largest integer less than or equal to r. For example, the floor of pi is 3. The floor of 10 would just be 10. You'd sort of round down, basically. It forces you to round down no matter what you've got. You know, if you had 11.9, it would still round down to 11. Floor can be a little counterintuitive when it comes to negative numbers. So, for example, the floor of negative 5.1 is not negative 5. It's actually negative 6. That's the biggest integer that is less than or equal to. Basically, if you imagine a number line, you put negative 5 here. Negative 5.1 is here. Basically, the integer that you want that is to the left, or the one that you're exactly at. That's how floor function works. Okay, just in case you've never seen it before. What have we got? Let n be a positive integer. I'm going to let a1 be n, a2 be the floor of a1 over 3. So you divide by 3 and then you round down. A3, you divide the previous thing by 3 and then round down. A4, so you keep going. So we're forming a nice sequence. A5, you'd take A4 divided by 3 and round down, and so on. The number of positive integers n, between 1 and 1,000 inclusive, so 1 and 1,000 are included, such that none of A1, A2, A3, and A4 is divisible by 3 is... All right, we have some options, and we also have the none of these options. That could be it. Let's see what we can see. Now, 1 to 1,000, that's kind of big. And with all these 3's here, 1,000 doesn't really strike me as a number that's particularly related to 3. So what we might try and do is look at something smaller, say 1 to 20. That way we could list them all out. And we also might want to not look at A1, A2, A3, and A4, but maybe just A1 and A2. Try and get a handle on the count there. And then, maybe A3 will add in a little later, maybe go up to a bigger number and work with A3s. But let's just try something like 1 to 20. And just to see if we can notice any patterns, any possibilities. You know what? I should have done 10. If I'm doing 20, 10 on the first row, 10 on the next row. I spaced things out a bit too much up here. Go, and 11, 12, 13. So I'll write the n, or A1, I guess it is, up on top, and then below I will write A2. So A2, 1 divided by 3 is a third. Round down, you'll get 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. So you'll notice the A2s come in groups of 3s. And I suspect the A3s would come in groups of 9. Which we might get to in a little bit. Okay, so the 3, so 3, 3, multiple. So we're going to eliminate the multiples of 3. How many multiples of 3? 6 of them here. Okay, and then down below we eliminate, so 0 is a multiple of 3. Not 2. 3, and then these 6s. So it looks like things come in multiples in groups of 3. I would be tempted at this point to possibly add in 0 here, just to complete the groups of 3 sort of feel. So we'll keep that in mind. But what can we sort of spy here? So some numbers have both A1 and A2 be multiples of 3. So we get 6 red numbers to eliminate from 20, and we get 8 or 9 if you count this guy here. 8 blue numbers to eliminate, but 2 of them, or alternatively you might view it as 3 of them, are sort of double counted when they're eliminated. So that's something to watch out for. How many are we actually left with? So we'll just do a quick count here. 1, 2, 3, 4, 5, 6, 7, 8. So we get 8 of them left over with 20. Doesn't really matter if you add in 0 or not, because it's not going to be counted. So you know what? I'm gonna add in 0 when I do this. I know they're going from 1 to 1,000, but that's because 0 isn't going to be something that we bother to count, because 0 is already a multiple of 3, so why bother with it? But I'm going to add it in just for some sort of completionist sort of work. So we get a red and 2 threes, and that happens a couple times here with multiples of 9. So I'm actually gonna group things in terms of the first 9 numbers. And so I guess we'll go up to 26. All right, so when we do that, properly space out our rows, I get 0, 0, 0, 1, 1, 1, 2, 2, 2. Nice, clean blocks. And if we were to go one more, 2 divided by 3 is 2/3, so that rounds down. So these would all go to zeros, these would all go to ones. So what's really going on each row is sort of what's the closest multiple of 3, or a multiple of 9 if you're down in the next row. Now let's take a look at what we would eliminate here if we were doing A1s, A2s, and A3s. I'm going to start with the A3s here. So 9 of these, a third of the numbers thrown out right away. Then threes and threes and threes. Nice little pattern there. So that's another third of the numbers, but there's a little bit of overlap. And then, oops, don't want to use blue, I want green. Those are gone. I don't really need to worry about this top section because all these numbers are already eliminated, but I'm looking for patterns here. So the 9 would be eliminated even though it was already eliminated by the 3. 12. And so what would we be left with? Nothing up here, and then 2, 4. We're left with 8 there again. Now, it's different than the 8 here because we had a whole extra row, because I'm now looking at the A3s. We get 8, and we can sort of notice some patterns. Okay, if we look at, these are big blocks of 3. The first one didn't do anything for us, didn't count. And then it looks like then within each of these, you've got 3 blocks of 3. And again, the first one doesn't really do anything. Blocks of 3, and then the first one doesn't really do anything, gets eliminated. And then inside each of these blocks of 3, the first one doesn't count, but the next 2 do. So, looks like we sort of have a recursion here, or a pattern, or like maybe like a fractal or something, sort of a pattern of what's going on. So if we take a stretch of numbers, it'd have to be a power of 3, but if we take a stretch of numbers, let's say 3 to the x times y, up to 3 to the x is y plus 3 to the x minus 1. So I guess another way to write this might be 3 to the x plus z, where z is in this range. What numbers are you going to get? You're going to get... so what I'm trying to say is this range of numbers, you should break it into blocks of 3. And the first block doesn't count, and then each of these blocks breaks down into 3. but then the first block won't count. And then each of these should break into 3. And the first one doesn't count. So it looks like we lose 2/3 each time. So for, when we're looking at A4s, a third of the numbers will be thrown out. And then A3s, another third will be thrown out. And then another third. And then another third. So it looks like we keep 2/3 of the numbers as we go along here. And if we were going a little bit further, like if we were generalizing, if this question wasn't about a to the 4, it was, or A4, maybe it was AX. Yeah, so it was AX. I don't have to write this as general as I'm about to write, but I want to see if I can notice a real good pattern. When it comes down to AX, this would just be whatever Y is, right? The whole thing would be Y. But everything else before this, there'd be a group up here of 0s and 1s and 2s. And then from those, there'd be 0s, 1s, 2s. Well, no, so if that's one, I guess we haven't really experimented with what happens. So those wouldn't be 0s, but they'd be 3Ys. 3Y, 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 and then you'd have a break, and then 3Y plus 1, 3Y plus 1. And then you'd have a break, and then 3Y plus 2, 3Y plus 2. That's how it seems to go. And then up above here, you have 9Y for a bit, and then 9Y plus 1s for a bit, and then 9Y plus 2s for a bit. And then over here, 9Y plus 3s for a bit, which is still 3 times this. So you're definitely breaking into your chunks here. And so the Y, let's ignore that for a moment. But once again, a third, all the 3Ys here go away, but you're left with 2/3 are still allowed. But then a third from the next layer is left out, and you're left with 2/3 here. And so at each layer, you only keep 2/3 of the number. So 2/3, 2/3, 2/3, all the way back down to A1. So how many of these are there going to be? Oh, sorry, this would be x plus 1. This would be AX. Because the first row is sort of like dividing by 3 to the 0. So there will be x of these. So that's how many numbers are left in a particular range like this. So now, for where we're dealing with A4s. So for 3 to the 4, that is to say 81, each block of 81 numbers gives only 16 numbers that survive. Right? So from 0 up to 80, only 16 numbers. Now 0 won't count, 0 won't be allowed in because it's already a multiple of 3. So it's really 1 to 80. Okay? But we'll say 0 to 80. Then 81 up to 161. The next group will have 16 and so on. Okay? So how many groups of 81 are in 1,000? Can't use a calculator, so let's just quickly long division. 81 goes into 100 once, and then Leaves 19, bring down the 0. 162, so 12, 162. So 12 groups of 81, so each of these groups gives me 16. And that's 72. So 192 numbers, and then we've got the last 28 numbers. So that would be starting with 81 times 12, because each group starts with a multiple of 81. So 81 times 12 is 2. 162 plus, so 972, 973, all the way up to 1,000. So I just need to know how many of these are included. Now, so those are A1s. Some of them will be eliminated. Then we jump down to 333s when we round down those, and this will be 332? No. Well, this is the first bit of the group, isn't it? The first third of these, which should be the first 27 of this sort of next group of 81, the first 27 of these won't count, and then there'll be 1,000, which isn't a multiple of 3, but when you divide by 3 and round down, it is. So none of these should count. Yeah, none of these should count, because if I've got a group of 81, so that would be 972 to 1,053. The first 27 of them don't count, and then we've got 28 numbers here. Well, sorry, 29 numbers technically. But these ones are 333s, so they don't count either. Yeah. So it should just be 192 numbers count. Every group of 81 gives me 16, but, and this is the larger point, we've cracked this a bit more. So if this were a more difficult question, if this were a written question on the Alberta contest, or something like question B3 on a Canadian senior paper or something like that, I understand exactly what numbers will be left in and left out. There's sort of this nice breaking into blocks of 3, and only the last 2 blocks might have numbers that can count. You just keep going all the way up to, a multiple of 3, and then the 2 numbers after it. So it's 2/3, 2/3, 2/3 are saved each time. A third is thrown away each time, so I understand exactly how this works. So I'm really satisfied with that. We didn't just happen to number crunch our way to an answer. It is 192, and that should be B. There we go. And that finishes off our 2011 paper. Well, it finishes off part 1. Of course, we do have part 2, the 3-hour written competition. If you want to practice part 2 from our 2011-2012 school year, that's what I'm going to be going through next. If you're just looking for more part 1s, feel free to browse around the channel. If you're looking for more multiple choice contests, feel free to browse as well. In fact, yeah, if you're just looking for more math contests in general, you're more than welcome to see what I've got in store. Feel free to subscribe to be kept up to date. Like the video if you've enjoyed the question or the contest itself, and if you ever have a different approach, feel free to let me know in the comments down below. I always like seeing new approaches. But thank you guys so much for watching, and I'll see you for more math